Good morning, grade 7. Hope you are all doing well. This is Miss Pamela giving the physics course. Today we are going to study chapter 5, section 2, forms of energy. If you can all please open your books on page 151 so you can follow up with me. In the first section of this chapter, we talked about potential energy and kinetic energy. We defined them, we talked about the factors that affect them, we talked about how we can calculate them and the rearrangements of their equations, and we took several examples. Today we are going to talk about forms of energy in detail. First, we are going to talk about mechanical energy. Mechanical energy is the form of energy associated with the position and motion of an object. So it is associated with both the kinetic energy and the potential energy. Examples: a moving car, since it is in motion, so it has mechanical energy. A trophy on the shelf, because of its position, it has mechanical energy. A ball thrown in the air, because of its motion and its position, it has mechanical energy. Now we are going to talk about how to calculate mechanical energy. Since mechanical energy is associated with both the position and the motion of an object, so an object's mechanical energy is a combination of its potential and kinetic energy. You can find an object's mechanical energy by adding its kinetic energy and potential energy. As you can see in the equation in front of you, mechanical energy is equal to potential energy plus kinetic energy. And of course, the unit of energy is joules. As we can recall in section 1, we took the equations of potential energy and kinetic energy, which are associated with the mass and the velocity, or with the weight and the height of the object. Now we are going to talk about how we can calculate the potential energy and the kinetic energy of an object by rearranging the equation of mechanical energy. So as you can see in the figure in front of you, to calculate potential energy, we use the following equation. Potential energy is equal to mechanical energy minus kinetic energy. Of course, the unit is in joules. And to calculate the kinetic energy, you also use the equation in front of you. Kinetic energy is equal to mechanical energy minus potential energy, and the unit for each kind of energy is joules. So we have the equations that we took in section 1 to calculate potential energy if we have weight and height, and to calculate kinetic energy if we have the mass and the velocity of the object. We can also calculate potential energy and kinetic energy using these equations if we know the mechanical energy of the object. For example, a football thrown by a quarterback has both potential energy and kinetic energy. The faster the football moves, the greater its kinetic energy. Why? Because it has a greater velocity. The higher the football, the greater its potential energy. Of course, because it has a greater height. You add the potential energy and the kinetic energy of the football to find its mechanical energy, like we already explained. The football has 32 joules of potential energy due to its position above the ground, as you can see in the figure in front of you. It also has 45 joules of kinetic energy due to its motion. The total mechanical energy of the football is equal to 32 joules, which is the potential energy of the football, plus 45 joules, which is the kinetic energy of the football, equal to 77 joules in total. Now we are going to talk about the relation between mechanical energy and work. So an object with mechanical energy can do work on another object. And the more mechanical energy an object has, the more work it can do. So whenever an object has mechanical energy, it can do work. And the more the mechanical energy it has, the more work it can do. Other forms of energy. An object can have other forms of kinetic and potential energy not associated to the motion or position of an object. So an object can have energy other than mechanical energy, which is associated with the position and the motion of an object. Most of these other forms are associated with the particles that make up the object. Number 1. Thermal energy. The particles in an object are constantly in motion. Thus, they have kinetic energy, because kinetic energy is the energy related to the motion. The particles in an object are arranged in a specific way. Thus, they have potential energy, which is associated with the position. Thermal energy is the total potential and kinetic energy of the particles in an object. So particles in an object are moving and they are arranged in a specific way. So they have kinetic energy and potential energy. The total potential and kinetic energy of all the particles in an object is called thermal energy. An example associated with thermal energy is when ice cream melts. You might have wondered why your ice cream melts on a hot day. Fast-moving particles in the warm air make the particles of the ice cream move faster. So warm air around the ice cream that you hold in your hand are moving fast. So they hit the particles inside the ice cream or on the surface of the ice cream and make them move faster. As the kinetic energy of the particles increases because they are moving faster, their kinetic energy increases. So as this kinetic energy increases, so does the thermal energy of the ice cream. Eventually, the ice cream melts. So it is all related to thermal energy because the fast-moving particles around the ice cream make the particles on the surface of the ice cream move faster. Number 2, electrical energy. Electrical energy is the energy of electric charge. Some important examples of electrical energy is the energy in lightning. So whenever you see a lightning bolt during a storm, think about the energy that it has, and this energy is electrical energy. It is also the energy in batteries and electrical wires used to run electrical devices, which we use every day. And you can also think about when you feel an electric shock when you touch the doorknob, this is also electrical energy. Number 3, chemical energy. Chemical energy is the potential energy stored in the chemical bonds that hold atoms and molecules of chemical compounds together. So as you know from your chemistry course that there's something called a chemical bond that holds atoms and molecules together. The energy inside this bond is called, or the potential energy inside this bond is called chemical energy. For example, the energy in the food we eat, in the matches that we light, and in our body cells. Note, chemical energy is released when the chemical bonds break. So whenever there is a chemical reaction, chemical bonds break and other bonds form, this is when chemical energy is released. Number 4, nuclear energy. Nuclear energy is the potential energy stored in the nucleus of an atom. Nuclear energy is released during a nuclear reaction. So the energy inside the nucleus of an atom is called nuclear energy. So what are nuclear reactions? There are two types of nuclear reactions. Nuclear fission reactions, which occur when a nucleus splits. These reactions are used by nuclear power plants to produce electricity. Number 2, nuclear fusion reactions occur when the nuclei of atoms fuse or join together. These reactions occur continuously in the sun, releasing tremendous amounts of energy. Of course, nuclear energy. So these are the two kinds of nuclear reactions in which nuclear energy is released. Nuclear fission, which is used to produce electricity when a nucleus splits, and nuclear fusion, when two nuclei or more than two nuclei meet, and it is the kind of reactions that occur on the sun. Finally, number 5, electromagnetic energy. So electromagnetic energy is the energy of electromagnetic waves. Electromagnetic waves are waves that form from moving or changing electric and magnetic fields. Examples: the energy of sunlight, the energy in microwaves used to cook food, the energy of X-rays used to examine patients, and the energy of ultraviolet radiation, infrared radiation, and radio waves. So all these waves are electromagnetic waves, and the energy they have is called electromagnetic energy. Please, as a homework, solve the math analyzing data problem on page 153 and numbers 1, parts A, B, and C, plus number 2, parts A, B, and C, page 155. Please, your homeworks must be submitted to me by Thursday morning, April 2. Thank you and good luck.